we've got Sharath Gokula, Director of Data Science and Analytics at Sam's Club, who will talk to us about how the retail sector is enabling faster, better data-driven decisions using causal methods. And as always, get your questions ready on Slido.
Good to see you all, and thank you for having me. We've got two options. We could start with the joke that I've planned, or we could do it right at the end. Joke? All right. How many causal researchers does it take to solve a problem? It's not mine. I heard it somewhere. So how many causal researchers does it take to solve a problem? The answer is one, but they need parallel universes. Yeah, I figured if it doesn't work with this audience, it's probably... All right, so when I was thinking through this presentation, I wanted to think through a first principle approach, a first principle argument to the approach that we've taken at Sam's Club. And that's what this is going to be. Yeah, let me start off with an introduction of what Sam's Club is. Sam's Club is one of Walmart's companies. So you need to be a member to purchase something at Sam's Club. It's called a membership retail model. We think of ourselves as a market-leading technology retailer. So technology and convenience being the core differentiation. There's a lot of other ways you can differentiate in the retail sector. We think of it as technology and convenience being a major differentiator. We are pretty big, billions in revenue, 600 clubs, and over 100,000 associates. So this is generally the retail landscape. When you think of retail, it's and you compare it to, say, let's say a purely digital company, it's extremely complex in nature. So you have, of course, the e-commerce, which resembles any other digital footprint. But you also have other business processes. You have operations. You have functions like merchandising. So this is the act of buying and selling product, negotiating, and so on. And then you have supply chain, which is the act of procuring something and bringing it to where it needs to be sold through that distribution channel. And you, of course, have marketing and membership, right? Your classic acquisition, retention, engagement, and so on. And then you have platforms that bind everything together. Some are in the form of processes, which are human-led. Some are actual digital engineering processes. So the point being, it's a very complex ecosystem. There's a lot of layering of technology. There's a lot of layering of business processes, operations, and so on. It becomes really difficult to measure anything. And let's go into what my team does. So my team, think of any tech investments, which enables any of those functions that we spoke about. My team either puts a dollar value to any of the tech investments and what the return of an investment is. Or let's say you're thinking of let's say putting some technology in a warehouse. What is the value of it? In financial terms, from a net present value standpoint, if you're trying to get acquire a customer, what's the LTV associated with it? That's what we are into. Now, this is where the first principle argument starts, right? And I think this is where the divergence happens between, let's say, when I wanted to become a data scientist, the main reason that I wanted to do it is because there is this natural search for truth. You don't want to accept the status quo. You want to go deep. You want to look at all of these small little pathways, try to understand what this is, try to understand the real nature of things as they are. However, in an organization, we really enable decision making. That's our core role, right? So while it's really good to go really deep and try to understand the true nature of things, with organizations, there's a lot of other things like bias to action, speed to insight, that really matters. And there's a classic conflict that happens when it comes to, when it comes to this sort of dynamic between data scientists who really want to be absolutely accurate with what they're trying to measure versus versus the organization and what the organization stands for and how an organization truly operates. So the real question we need to be asking ourselves is, do decisions change, right? Let's say the decisions are fairly binary in nature. I make an investment or not. Do decisions really change if the accuracy of my point estimate changes? So that's really the main point here. So if, say, let's say you say the cost of acquiring someone is $10, that's what it is right now. Eventually, there's this new technology which brings it down to $3, for instance. If, say, the range you could say is between, say, $3 to $5 or $4 to $5, does it really matter if it's exactly $4 or $4.2? Because ultimately what happens, a lot of these decisions are binary, and we are enabling these decisions. And so now what happens in the case of e-commerce, for instance, we have A/B testing. It's widely used. People understand what it is. There's mass adoption. I feel it's a really great tool, not just because of the technology, but it allows you to understand risk and reward. It allows someone to say that, okay, this is the confidence that I have with the data. There's also this aspect of repeatability associated with it, so you generally have confidence that the results are fine. People are able to understand the risk in terms of false positives and false negatives. And then, therefore, the business person understands it in a language that they're used to. They think of risk and reward, and then, therefore, they can make these decisions. Also, you can operate at scale, right? Like with minimum changes in methodology, you can operate at scale with A/B testing. I think that's a core differentiator here. Now, what happens, I borrowed this from the Shopify blog, and when you have a complex system like retail, you can't really A/B test. And so what that means is you're forced to then take these other approaches. In a lot of cases, I'll say that even quasi experiments are not possible. One, because it requires a lot of change in mindset, and to bring about that culture change, it takes a long time. The second aspect is just operationally sometimes really difficult to do it. So imagine if I know that these are like-to-like clubs, and I want to make a comparative set, it's very difficult to deploy the operations in a way where you can say that you can layer and separate the operational deployments in the form of making it a comparative set. So naturally, a forced move for us is to go for the counterfactual methodologies, and that's what we are working on, and that's what we are building on. Now, given all of this, I wanted to say that generally we look at accuracy as the main point of what we are trying to, we hedge it on accuracy and say that the estimates need to be really accurate. But if you think of it, reusability is an important aspect. So if I build what we call frameworks, and I'll go into that in the next slide, we want to make sure that some of these frameworks can be reused over and over again. So let's say it's a promotion-related problem for a specific audience. Then you need to be able to use it again. Explainability is important in some cases, especially when you're trying to create mass adoption among the business group. They don't speak the same language as us, so sometimes the question is as simple as, why is your black magic better than mine, right? My intuition tells me that it's $5, how are you so sure? So sometimes explainability in the way they understand is important. I also say speed becomes important. So if I have to make a decision in 2 months, then there's no point of giving me an absolute accurate answer in 10 months, right? That's how organizations work. And if you really think of how data science teams are evaluated, they are evaluated based on the quantum of decisions enabled and the quality of the decisions that are enabled in some way. And so speed matters. And so our approach has been to think of a modular way of solving this. We've thought through frameworks. And a framework is a mix of, I think there's a lot of components that contribute to a framework. We've gone through a list of problems that we are trying to solve, that we've been asked to solve over the last 2 years, and try to come up with frameworks. Granularity of the data seems to be a key factor. So think if it's something that affects a member versus something that affects versus something that's deployed at a club or in a store versus something that is deployed across all the network or all the chain, versus, let's say, if it's something at an order level. So all of these have different problems. You deal with it very differently. Then there's also aspects of nature of the outcome. Sometimes you're trying to measure, let's say, a forecasting problem, something related to an algorithm. And these algorithms, like computer vision algorithms, improve over time. And these could be, they improve because more the data, it improves. In some cases, it's as simple as in a store, you haven't placed the camera correctly. So now that you know that the camera needs to be placed correctly, the algorithms therefore improve, or the return that you have naturally improves. And so there's a lot of reasons why that could happen. There's explainability that we spoke about. There's rollout strategy. In some cases, of course, ideally, we want to have a proper rollout strategy. It so happens that it's very difficult to influence businesses to roll it out, get everyone aligned. And so if you're rolling it out across clubs or across warehouses, across a member group, all of this matters. And so we've looked at all of this, come up with a bunch of frameworks, and frameworks look something like this, right? So the first one, I won't go through all of it, but let's say reduce shrink in clubs. So shrink is, how do I put it the most diplomatically? It's when, let's say you bought $100 of inventory and you just have $90 that you can account for. You can physically place just $90. So $10 magically disappeared. And so we call it member-related shrink. So sometimes members put things into the cart and they forget to pay for it. This, of course, happens magically, and across the retail industry, and then that's what we define as shrinkage. So if we are trying to solve problems related to shrinkage, and if it's member is customer for us because that's the model, then there is that pertains to a particular set of problems. And so that's a framework. Similarly, you would see a few others. Now, the main point being, in some cases, some of these frameworks, especially if you're doing a promotion once, if it's a member level, you know everything about the member, which is our case. You have something as simple as matching, right? You don't have to go any further. People need a rough estimate on what the cost of acquisition is. Something as simple as matching. Let's say in this case, in a particular month, there has been a deployment. That's the only time the technology is going to be deployed, and that's a big bang deployment. It just seems to work. In some cases, especially, let's say, you put a technology in a warehouse, and now you're optimizing for transportation. And so you'd have shipped something from Dallas warehouse, for instance, when I live in California, but now you have the capability of shipping it to me from California. This pertains to a very different and specific kind of problem. And in those cases, it becomes really difficult. So you can imagine that the whole network is connected. Whatever you do, one part of the network affects the other, and so on. You want to come up with, and of course, there's also this concept of operations being something that affects. There's multiple features being released at the same time. So you have or multiple technology investments happening at the same time. So you're hit with all of this. And then in those cases, you need something more complex. So these are my last two slides. And the point is, when we think of A/B testing, there's a reason why we have to think of how the industry is going to adopt causal technologies, because that's absolutely important for good decision making. And if you think of why A/B testing is really successful, it's still right now the point of parity. If you will, it is the incumbent. We can model causal technologies like we model A/B tests. And the reason why it works, I understand the risk reward. There's confidence intervals. Someone tells me, how long will it take for you to give the results? There's power analysis. You can be very specific about it. And the more these technologies start to resemble A/B tests, I think it's going to be adopted more widely. And therefore, it's important to speak the language of the business folks who are not as technical. And in conclusion, within organizations, it's difficult to sell causality as a problem statement. And it goes back to the point, the reason everyone becomes a data scientist is because you want to work on technology that is cool. You want to solve all the problems. I want to understand the world the way it is and all of these things. And it's great because I think that idealism is what's brought us this far. But we should really be thinking of causality as a solution to a complex problem and not the problem itself. So that's what I have. Thank you.
Thank you. We have got quite a few questions. We've probably only got time for one or two, but I'll go through those. Just for all those who are asking questions or using Slido, you can upvote the questions. So I'll just ask the most popular ones, just for everyone there. So first one was, how does data quality affect your confidence in the accuracy or explainability of a framework?
Yeah, $1 million question, right? So, I mean, it's probably the main thing. If, say, your data is good, you can probably add and subtract a few things, and by intuition, you know what is going on. But if the data is bad, however good the algorithms are, and this is always the concept with computer science, right? There's garbage in and garbage out. So, of course, data quality is a scale, and there are practical ways how you can measure data quality, but it's the same everywhere. Like, data has to be in good shape for any of these technologies to work. If it's machine learning or if it is any sort of causal inference work.
Absolutely. So just ask one more, it's become a very popular question, which is for quasi-observational settings, do you have a standardized approach to test the robustness of the counterfactual estimations?
Yeah, again, I think that's the problem that I was speaking of. You know, and it's a very important question. We do a lot of, there's some backtesting that you could do. There's, you know, you can do refutation tests of different types. So there's ways to do it, and we are doing some of it. But the question specifically is there a standardized way to do it? And I don't think a standardized way will be there, but it's probably going to be like 4 or 5 standardized ways. So we are currently looking at a bunch of ways to do it, refutation tests, backtesting, and so on, to come up with you know, some way of standardizing this.